Hi, friends. I know some, not everyone.
Yeah, I was wondering,
Hello.
James, if we'll have time to do a round of intros, or what are your thoughts on that?
It might depend how many people we have if we can actually do intros for everyone, but people can at least write in the chat their name and where they're from.
Yeah, agree. And how about, since we're 1 minute in, how about we do some intros of ourselves and let people filter in while we do that?
Sounds great.
Cool. Amy, do you want to start?
Sure. I'm Amy Goldman. I'm at Pacific Northwest National Laboratory, and I co-lead WHONDRS with James. And I don't know what else would be helpful to know right now, but I'm happy to be meeting with all of you.
Nice. Avni, you want to go?
Sure. Hi, everyone. I'm Avni Malhotra. I'm a staff scientist at PNNL, Pacific Northwest National Lab, and I've been engaging with this group for the last couple of months, several months, and excited to get writing, I guess.
Okay. Who else needs, we can't introduce everybody, sadly. Brienne, you want to introduce yourself though? And then maybe I'll go.
Yeah, I don't think you've ever called me that before. Really threw me off. My name's Brienne Forbes. James usually calls me Bree. That's why I got confused. I am a data scientist at PNL. I've been around for a little over 2 years now, and do a lot of the communication. So you've probably seen me in your emails.
Awesome. Anyone else that we need to introduce today? Okay. All right. Well, I'll introduce myself then. I am James Stegan here at PNNL, Pacific Northwest National Lab. As Amy mentioned, I co-lead WHONDRS with her and am trying to help with this effort. So I think what we're going to do is, and if anyone went to the Neon webinar, I guess maybe that's the right word. I see Zach here, so it's triggering me. If anyone went to that, you'll see a lot of similarity in these slides. So anyways, just FYI. And so what we're going to do is go through some slides, as I just said, give some context, update on the current results that we're looking at, which have been a team effort among several people that are here and more than that. And then we'll talk about some practical elements. So, because this really, Amy, I don't know if you were going to say this or not. Sorry if I'm jumping ahead of you. Amy's going to lead off the slides. Just for context of what is this meeting, if it's not totally clear, we've come a long way in doing data analysis, and we're at the point of writing the manuscript for what's called the ICON ModEx project, which was AI-guided iterative science done with y'all and many more people to understand and predict sediment respiration across CONUS, contiguous US. So this is a context to practicals, move the ball forward type of meeting. Feel free to use the chat. Amy, I think you are going to lead off, and I'm going to share my screen, I believe.
Yes, that is the plan. We do have someone in the list of attendees that is like sharing the whole grid of attendees, and the name is grid, and I am confused by that. Does anyone know what that is?
I was just trying to Google it, and it says if someone has added like a third-party app, like for transcript or something, it could show up.
Okay. Great. I'm gonna assume it's fine. Also, we are recording and plan to put this on YouTube.
Great. So I just spotlighted you, Amy. I don't know if that helped at all.
looks like there's a star next to me, and so that's always an exciting time.
Great.
Okay, so yes, thank you all for joining us here today. James did cover some of the intro things, but we'll see what there is left to say. I want to thank you all for being here and also thank our broader team and our many, many collaborators across the world for making this work possible. And then also want to thank our funding agencies. If you go to the next slide, James. Thank you. We've received support through the Department of Energy Environmental System Science Program, and also Parallel Works has received support through the DOE Small Business Innovation Research Program. So thank you to them. So James sort of covered this outline, but I'll go through it again anyway. So I'm going to go through a little bit of common foundation information, just so we're all starting off on the same page. And then James will go through the introduction and motivation for the manuscript. And then James and Bree will talk through some methods. Avni will go through the results and main points of the manuscript. And then James will get into the governance and next steps. So getting onto that common foundation, the Worldwide Hydrogeochemistry Observation Network for Dynamic River Systems, I think you're all familiar with likely. WHONDRS was founded in 2017. And WHONDRS is a global consortium studying river corridors. So one goal of WHONDRS is to accelerate river corridor science. I'm going to go to the next slide. Thank you. By developing data, knowledge, and models that are transferable across river corridors. And this is key to enhancing predictive capacity from regional to continental to global scales. Another goal is to work with folks outside of our immediate science team and to find opportunities for mutual benefit. So that's one of the things we're doing here. So we often ask what data or connections or information are people interested in and how can we work together to achieve those interests. And so this set of goals aligns with the ICON science principles, which we use as the foundation of WHONDRS decisions. ICON is simply an acronym for a set of principles: integrated, coordinated, open, and networked. And these principles act as a framework for people or projects that are motivated by these two goals that I mentioned: mutual benefit with people beyond our immediate team and transferable knowledge beyond a single study site or focal area. And so this set of principles just helps you guide you to reach those goals. And ICON Principles guides WHONDRS to intentionally design work that is integrated, coordinated, open, and networked. And what that means in this context is integrated across physical, chemical, biological, and/or social attributes and scales to encourage diverse insights, coordinated with other projects to use consistent protocols and methods to enable transferability and synthesis, open and fair throughout the research lifecycle to promote knowledge exchange and engagement, and networked, whereby research is designed and/or implemented with a broad range of interested parties to facilitate mutual benefit. So if you're interested in learning more about ICON, I suggest you check out the ICON Science Cooperative, which is developing resources to help projects apply ICON in their work. James and I co-lead that with Sujata Imani. So WHONDRS operationalizes these ICON principles to achieve its science goals through participatory science. And as a very brief overview, and something that many of you are familiar with if you've engaged with WHONDRS, this includes designing studies in an open, collaborative way, sending free sampling kits out to global volunteers, generating data in a centralized space for consistency, and then publishing that data openly and creating opportunities for people to learn how to work with those data. So this approach has been really, really exciting. WHONDRS has worked with collaborators to collect samples from hundreds of locations globally, with a specific focus on the continental United States through a series of studies since 2018. And this has resulted in numerous published data types, including high-resolution organic matter characterization. And WHONDRS has also facilitated several open collaborative analyses and writing opportunities like the one we're discussing today, which have developed both scientific innovation and also new relationships, which we're hoping is one of the things that will come out of this for all of you. So there are a multitude of outcomes that come from doing participatory science in this ICON guided way. So that's the sort of common language, common background that I wanted to cover. And now I'll hand it over to James to talk a little bit more about the science underpinning this manuscript.
Okay, thank you. Hopefully you can hear me okay, and I'm still sharing my screen. Just have one screen today. And okay, so thinking about then this meeting is like moving towards the practical elements of writing this paper. So then we can start to think about how is the paper actually structured? How is it motivated? Kind of how do we flow through it? The rest of the slides will roughly follow that kind of trajectory. So first thinking about like how is the paper motivated? And the idea is to motivate it from the perspective that stream networks, river networks are sometimes thought of as the veins of the earth, very quite critical for transporting and transforming materials as they move towards the ocean. Major parts of the carbon cycle. I'm not going to belabor this too much, just to point out that Cole et al. In 2007 made this point that these systems are a vital part of the global carbon cycle. They are not simply transporters of carbon and materials. And Baton all made that point last year in Nature, river networks being the largest biogeochemical nexus on the planet. And so in that context, thinking about, okay, what are the major drivers and unknowns and uncertainties in these kinds of systems? And this particular paper and the associated work is motivated thinking about that the sediment part of stream networks, when you walk up to a stream, the stuff you're standing on, basically, that's often, but not always, but often a major biogeochemical reactor in the system, transforming a lot of organic matter, generating CO2, methane, other materials. But there's a lot of uncertainty there. It's never been approached in a holistic way from the bottom up, from a mechanistic perspective. And so we're motivated from those sorts of observations and insights. And so that's very high level. Then we can start to zoom in here. What is the more specific motivation? And we can start by going through a study, a WHONDRS study that was done in collaboration with a lot of folks across the world, most of it focused within the contiguous US in partnership with NEON and others. And I'm going to step through that. This study is not in the paper, but it's a bit of a foundation for motivating this particular paper. So in 2019, short story, this participatory effort to get samples from stream networks, rivers, et cetera, across the world, again, most in the US, collecting water and sediment samples. And we brought those materials into the laboratory and measured respiration rates on sediments, just in little small bioreactors. These are not field scale measurements. Lots of other data types. I'm not going to go in the details of that today. The point is doing very consistent work across lots of different streams and rivers to start to get at respiration rates, in this case of fine-grained sediments. For context, how these is measured in the lab, so you got a little bit of sediment, about 10 to 20 grams, in with river water in a small vial, shown on the left there. It's shaking, it's a slurry really. That pink dot is an optode. It's imaged with a fiber optic system. You measure oxygen consumption through time in this system. You can see some example data on the right there, linear slope, an estimate of respiration rate. That is the key data type. That is the response variable, the thing of interest for the initial study I'm walking you through right now and the paper that we are writing together. Okay, I can't see the chat, so shout at me if something needs to be, if I need to stop or anything like that. And please stop us if something's not clear. So the whole point of this is to bring us all along. So to
James,
get these, oh, yep,
Nick
oh, what you got?
has his hand up.
Yeah,
I
hey,
don't
on
know if
that-
you want
Oh,
can you hear me?
questions as we go.
Yep.
Yeah.
That water in your last figure, that was local river water from where the sediment was collected. Is that right?
In this case, yes, I'm quite sure. Someone can correct me if I'm wrong, if I've misremembered, but it should be native stream water physically adjacent to where the sediments were collected. Yes. Yeah,
Okay.
thanks for. Let's see. So there's a lot going on in this map. The simple point for now, two things. Red plus symbols are where samples came from for this initial 2019 sampling effort. We can forget about the pink for now. The black dots will become relevant many slides from now. I think when Avni is speaking, you'll see some contour plots. Those contour plots are based off those black dots. So Avni will speak to that later. Basically, this is just showing pretty good spatial distribution of sites. Not perfect. There's some missing regions and things, but that's what this first study was using. And Stefan Gary, who I believe is on, I think I saw Stefan. He and Tim Scheibe led this paper based off of these data. And what they were doing, and of course there's a broader team, but what the key thing they were doing, and Stefan, I'm sorry if I misstate anything in your methods and your efforts here. There's a QR code to Stefan's paper. You can scan that if you like. So basically we got a whole bunch of sediment respiration rates. It's about, I think, 80 locations, something like that, across the CONUS. And then the question was, okay, can we build a machine learning model that is actually predictive? And the way this was done is using this method that Stefan's, the company Stefan works for, ParallelWorks, has this application, I guess maybe you could call it, called the Super Learner. And my understanding, and shout out Stefan if you need to, my understanding is the Super Learner has 15 machine learning algorithms within it. They are run in a test train approach, and the outcome that you get is weighted by the performance of each of those 15 different machine learning algorithms. So different kinds of machine learning are baked in there. So you get the kind of this ensemble outcome. And then you redo that. And you redo that in this particular case 10 times. So in that case, you're getting an ensemble of ensembles, which out the end gives you a weighted average prediction of sediment respiration rate as measured with oxygen per volume per time, as it indicates there in that kind of that pink box. So those 80-ish sites were analyzed using this approach, asking the question, can we build actually a predictive machine learning model that applies across the CONUS? And short story is like yes and no. So left-hand side, this is log 10 transformed predicted rates. X-axis is log 10 transformed observed rates. You can fit a linear function, and that's pretty nice and tight. That's the solid line. However, it falls well off the 1-to-1 line. That's the dashed, the black dashed line. Falls way off there. There's strong amounts of bias. We're not doing great in terms of capturing the absolute rates, being able to predict them, even if there's a strong correlation. So this is, again, we're motivating this next paper here. So this is one piece of motivation. Machine learning model is like kind of okay, but not awesome. And then, but to explore nonetheless, like what's possibly most important? Short story, out of 130-ish variables, data types coming out of high resolution mass spectrometry characterizing organic matter chemistry were the most important in terms of explaining variation within this model. And right, we didn't include the data slide to show that. It's not a key focus of the direction we're going now. So it's kind of an interesting thing. You can take a look at Stefan's paper. Stefan, you're on. Maybe you can shout out. Did I misrepresent anything thus far?
Nope, everything's great. I just wanted to emphasize that all the code is available. All the models are also available in open archives.
Awesome. And I was realizing didn't have my camera on. I'm sorry. Okay, so now that paper's published. Where do we go from there? And where we're going is into this new paper. So we're basically, if you think about the paper, we're basically in the introduction at this moment. And now we're going to go more into the approach and what the point of this next paper is. And now I've forgotten. Bree, are you doing this part, or am I gonna keep going?
No, onto me. Thank you. Yeah, so now that you've heard about the motivation, I'm going to touch more on the methods. So the underlying approach of this study is a model experiment iteration, or ModEx. So we first used the data from S19S, as James just described, as the initial input to these machine learning models, along with some publicly available geospatial and watershed characteristic data. While we found that, like James said, organic matter data is one of the most important variables, it is very difficult to scale up at this large scale that we're trying to get at. So we set out to see if we could improve the model with simple data, such as dissolved oxygen and these geospatial variables, but using this iterative ModEx method. So once we built the first iteration of the machine learning model, it then guided new sampling locations based on model uncertainty and environmental divergence. So then we widely advertise this opportunity for community members to sample at these AI-guided sites and sent sampling kits out to these volunteers. The data then was collected and was then added back into the model. The model was rebuilt, and then we were given new guidance for sampling locations. And we repeated the cycle for 18 months, every single month, for a total of 18 times. So this animation that you're seeing cycles through the different months of AI guidance on sampling sites. So many of you are familiar with these site maps because these are what were sent out to collaborators to say, hey, are you near any of these sites? Would you like to sign up, volunteer to sample any of these sites? You can see in the lower left the month cycling throughout, so you can see kind of where we're at. We're not going to get into the details of the two different map markers here, but they represent two different types of priority sampling locations. And this graphic shows the spatial shift in sites with each monthly iteration. So at the beginning, we see more dramatic changes in the spatial distribution, but as time went on, we saw a stabilization in the regions of priority. Go to the next slide. So by the end of the study, we had 142 collaborators that had generated 1,700 samples in the field only, with almost 5,000 subsamples over 18 months and across most of the contiguous United States. So together, the ICON and ModEx frameworks shaped this robust data set that ultimately resulted in an increase in model performance, which Avni will now describe.
Okay, thanks, Bree. So now I'll take you, so you've heard a little bit about the intro or the motivation for this paper and kind of the basic methods. So in the next few slides, I want to highlight where we're at with the analyses, the kind of results, and what we're thinking at this moment could be the main points of a manuscript like this. And of course, through the writing process, we hope to iterate over this quite a bit. And so all of your thoughts will be welcome. All right, so the way we're envisioning, oh, sorry, we should go back one. Okay, the way we're envisioning this manuscript, kind of the high level point that we want to make with this is more to demonstrate that this iterative model observation loop can significantly help us increase environmental predictability. So we're not entirely going to focus on sediment respiration as the most high level point, but of course we will get into the nitty-gritty of the science behind the sediment respiration too. So we're thinking of this, if you can think of these as kind of subheadings of a short format paper, the first point we want to make is a new AI-enabled scientific workflow. The second point we want to make is about a 1.5x increase in predictive power through these loops. And then the third point we want to make is getting into the predictors of that Kona scale sediment respiration. And we're hoping to target a short format journal. I think we're thinking to start with Nature Geoscience and then kind of work our way down. So next slide. All right, so now I'll show you, corresponding to each of those 3 points, I'll show you the main visual elements that we have so far. This is a very draft version. This is probably the most drafty version of a figure, but we'll start the paper off by describing this AI-enabled ModEx loop. And so we'll go over the different elements that are part of this loop. So most of this has already been described, but just to give you a very quick overview again. So we had these AI model guided sampling locations where we got these community samples, generated new data that are always immediately posted in a public place. And then the modeling happens also in an open and discoverable way with our partners here from Parallel Works that helped with or led the machine learning model part of it. And then it loops back into the revised model, which plus a representativeness analysis that then helps us guide where we need to get more samples from, and then the loop continues. So this is what we'll describe first in the paper, and then next slide. So we're making this claim that we can increase predictability of, various or whatever environmental predictor. So we're going to take sediment respiration as our case study and demonstrate how model performance increased substantially for Kona scale sediment respiration. So in this graph on the x-axis, we have our total number of samples. Each of these points, so we're either following the blue trajectory or the red trajectory. The difference between them is more in terms of how the data were processed. So let's not worry too much about this, but essentially as we went through our loops, our average model R square or explainability increased. So, we can say something like we went from a 0.2 R square to a almost 0.8 R square. So that'll be the second point. So we can go to the next slide now. In addition to that, showing those different loops, we can also show the first model and then the final model in those iterations. And so this should look very similar to the first one that James showed a few slides ago, right? So this was the first model that we had with kind of limited R square. And then at the end of all of our iterations, we were able to capture a lot more of the variability in sediment respiration, both observed, you can see both the observed and the predicted from the model here, and then our model R square going up to 0.72. So as you can tell, we're still kind of cleaning up the numbers, making them more consistent, but these are the main visual elements that we were hoping to have. So the next slide. So this is still part of that second point of how our predictability changes in the initial versus the final models. And this is another way of showing that, taking all of our data points, which are in black here, in both the original and the final, and then showing kind of this interpolated spatial coverage of the respiration rates. We've blocked out some of the numbers here because we're still tweaking them. But I think the points that will remain overall is that we've kind of decreased these extreme hotspots over time. So the more data we have, the more diffuse and kind of more, I guess, realistic the sediment respiration becomes. And then next slide, we can also look at the errors associated with the first model and the final model. And so the other point that we can make is that our errors also become a little bit more diffuse by the end of the final model. And then I think I can just go to the next slide. So in the third point or the third section of the manuscript, we can get into the details of what these predictors of Kona scale sediment respiration actually are. And here's a list of all of the different predictors that we had in our models. We're showing their feature permutation importance. I always forget what that means. Stefan, please correct me. But essentially, you're looking, so the higher the numbers are, the more important that predictor is, right? And then predictors that are correlated with each other are clustered together in these kind of shaded clumps as well. So this is a part of the manuscript where we would welcome, a lot of the sediment respiration expertise that we have in the room, kind of thinking about which ones of these should we highlight as key Kona scale predictors. Anything else that the team wants to add on any of the figures? Anything from, oh, go ahead, James. Oh, I can't hear you, but I don't know if that's just me.
Is it getting better?
Yeah, better.
Okay, sorry. Headset thing. So yeah, I put a couple things in the chat. People can take a look at those there. Nice work. And yes, Stefan is doing all this FPI work, and we tried to indicate the into the pipe person that was doing the stuff, like Micah Taylor was making maps and things, but there's tons of people that were actually doing a lot of work to lead up to those things. So that's all.
So after this, I was planning to kind of just show what the current state of the manuscript outline is. I can still do that if folks want. James, should I steal the share screen?
Sounds good.
Alrighty. Okay, so just to give you a sense of where we're at. Okay, so we have a basic outline, which I more or less just presented. Some main points in the abstract that we would like to make. And then we have some sense of kind of the motivation, and I think it closely aligns with what James presented, but no actual paragraphs written. The first figure draft that we're still working with the graphic artist on, and some of the main points that we want to make. We basically have each section kind of bulleted out, but no paragraphs written anywhere. And then these are the 3 points that I already presented to you. So we have each of our placeholder figures that are almost finalized. We're just still checking things for consistency. How the model loops changed over time, and the original and the final model, the variable importances and that discussion. Again, we don't have any paragraphs written out, and then those final and original and final maps of both the predictions and the prediction error. Yeah, so lots of work still to be done. I'll hand it back to you, James.
Okay. And something else I was pointing to before, I'll just say a tiny bit more. So like the stuff you're seeing here, kind of said this, I'll just kind of say it again. The way this has gone, just to kind of step back in like the higher level process, we had a kickoff meeting. I don't actually remember when it was. It was a while ago. Maybe it was a year ago or something. And from that meeting, we asked who would like to participate in the analysis part of this before we get to the writing. And several people self-nominated, jumped in there. And so like Bree Waterman is on. So I want to say, hey, Bree, awesome. Bree's been heavily engaged. I already mentioned Stefan, Bree Forbes. I don't see Sushant. I don't know that Sushant is here. Anyways, I want to shout out to him and Micah as other folks that are like been very hands-on. Let's see, Christy Sampson has been engaged as well. Am I missing anybody? I just want to make sure I'm shouting some names out to folks that have had their hearts and minds and hands in this for a bit here. Okay. If I missed someone, I'm sorry. Shout it out and we'll Mihal Brun, he's not on. He jumped in to help us as well. That was pretty fun. I think he's in Ireland. Found out about it and was like, yeah, I want to come and hang out with y'all. So he's been meeting with us for a while too. Okay, so I'm going to share screen again, and I'm going to go through a couple links that are in the deck, and let's see if this works. So in these big efforts, it's important that we're setting some expectations, team norms. How are we engaging each other? We start thinking about authorship. And so we have a couple documents. Again, they're in the slide deck. Maybe someone can put them directly in the chat if that's helpful. One of those is this code of conduct. In red here, encourage everybody to have a look, certainly have a look at least if you'd like, add some comments, suggested edits. This was made available at the first kickoff meeting, so it's unchanged since then. We asked for edits then. I don't think anyone added specific edits. There was a couple encouraging comments, nice. And my plan wasn't to go through this deeply. It's kind of fairly, at this point, hopefully standard stuff that we're all used to, expected behavior. We're talking about respect, open communication. We're not being nasty towards each other. We should be mentoring, encouraging, inclusive. We're inviting, we're listening, we're including, collective, collaborative, collegial. This is hard. Deadlines are hard. We try to set them, we do our best to stick with them. Things happen. We try to keep pushing forward. For me, the main point of deadlines, especially in a paper like this, is to make sure things aren't just getting dropped. We rarely hit the deadlines we set, but as long as we're pushing forward, at least in my opinion, we're doing good. Avoid high stress last minute situations. Yes, that's key. Unacceptable stuff, stuff you would expect in a document like this. We're not intimidating, harassing, no abuse of any kind of flavor. All kinds of examples of unacceptable behavior. We're not plagiarizing. We're not fabricating. Hopefully these things are already in your mind as professional scientists. Of course, what do? Well, if we're seeing something bad happening, we're going to ask you to please stop doing that and get on board. And we do reserve the right. If we got a real bad actor, we will remove you. We've done this kind of thing several times, hundreds of people thus far. As far as I recall, we've only had one, and we did remove them. And I'm glad we had set these expectations up front. They were obviously a bad actor. Reporting, what do? You can certainly reach out to any of us on the leadership team. That's me, Avni, Amy, Stefan, Bree. We have well, we didn't put the link in there this is it right here though, the anonymous Google form. Hopefully this is the right way to share it. Sometimes I screw this up. I can't, oh boy, I'm in trouble. Hold on.
All the links are already in the chat. I'll add the link to the
Awesome.
code of conduct.
Beauty.
Yeah.
Thank you.
Yeah.
Okay, so let's just say worst case. You're like, this team is not doing what they're supposed to be doing, whatever. This person right here, Stephen Collister, is my formal PNL manager. He's not engaged in this effort. You can email him. And lawn mowing just started, so this is going to be weird. Okay, inclusive, all the similar kinds of things. Reach out to us if there's trouble. Okay, there's now a lawnmower like 10 feet from me. This is crazy. Let's come back to the authorship stuff.
The sound on this side isn't too bad if you can think while it's happening.
Okay, I
Yeah,
will
we
try.
didn't hear it at all.
That's amazing. Okay, it's so loud. Okay, so authorship. If you've done work with us before, I hope this will look somewhat familiar. We've taken inspiration from the Dry Rivers Research Coordination Network and setting this up. The column B has me in there as an example. You'll see some numbers and things. Those are not meant to be what I have done. They're just examples. I'll change them. High level thing. This is all self-reporting. Okay, we all trust each other to be reasonable humans and report what we've done in as an objective way as possible. So there are two levels. There are who's going to be an author and what's the author order. And we're doing this using basically numeric scoring. The first level, who's an author? That uses this credit taxonomy. There's a link right there. You can follow it if you like. Credit has several categories of contribution. You can go look at their definitions. So over here, what you would do is you put your name in. Okay, so here's my name, here's my affiliation, here's my email, here's my ORCID. And then I go through and I say, okay, did I contribute to the conceptualization? Yeah, I feel like I did. Okay, I put a 1 in. Did I actively do data curation? Nah, not really. I'm going to leave that at 0. 1s and 0s, presence, absence. What it does is then it gives you a total. And the short story is right here. If that number is 2 or higher, you're a named author. If it's a 0 or a 1, thank you very much. You'll be in the acknowledgements. Just trying to be kind of cut and dry, objective about it. Okay, hold on. Okay, so shout at me if there's a question. So part 2 is how do we assign order? The way we're doing this is, if you think about the manuscript, this manuscript only has, a handful of standard sections. Sometimes we get a little bit more granular with other kinds of papers that have many more sections. But there's basically 6 elements here. Overall conceptual vision, manuscript leadership. Think of that as like in the space of like a corresponding author or like leadership team. And then there is introduction, methods, results, discussion, and associated data package. In this case, it's a 0, 1, 2, or 3. You can see it, they're defined right over here on the left-hand side. Again, you choose. Think about the introduction, like, oh yeah, I wrote that whole section. I had the vision for it. I outlined it. 3. I'm the driver of the introduction. For methods, I didn't write a single word and I didn't talk to anybody about it. All right, 0. I made a figure, but that's all I did. Okay, put a 1 in. I did like a little bit of editing, kind of some more than periods. I was thinking about kind of conceptual flow. That's maybe a 1, somewhere in there. Nothing is clear cut. You just have to interpret it as best you can. Put your numbers in, and you get a number at the end. It's a sum total. That should then define author order numerically. Whoever has the biggest number, you're the first author. If there's a tie, it goes alphabetical. So far, this has worked well. Haven't had any issues. I'm sure an issue will pop up at some point. Any questions? I know this is like a little bit to ingest, so you can pause and see if there's questions.
Quick question, James. So I can't remember what the meeting was. I mean, this was 4 months ago, it seems like. Were we all conceptualizing back then? Do you remember? I remember putting comments on Google Docs, and that's about it.
Yes, that was
a while ago.
More than 4. It might have been a year ago. I don't remember. I know the meeting you're talking about. That was the initial kickoff for this manuscript. So let's find that Google Doc. If it's not the same Google Doc, or maybe the history. So the reason I'm saying that is to self-reflect on this. You could go back and just look like, oh my God, I put in like 100 conceptual comments and I see those ideas in this paper. I feel like it contributed a lot to the conceptualization. I'm going to put a 3 up in there, or 2 or 3 or something, or 2.5, whatever, in the overarching conceptual vision. That's up to you if you see that heavy contribution, and it really is up to you. Is that well, I'm not sure if I'm actually answering the question you're asking. Is that in the spirit though?
Yeah. Oh, whoa, there's okay, I'm just now digesting that there's multiple. I thought it was just a 1 in all the groups. Okay, you've got 0 through 3 now too.
Yes, there's two stages. Stage 1 is the credit taxonomy, ones and zeros. So that's defined over here. Put in 1 for each that you contributed to. So, okay, Nick, in your case, let's think about that kickoff meeting. And you're like, oh, we should think about it this way. Think about it that way. How about this? What about this literature? You're conceptualizing. My opinion, I'd put a 1 there in the credit taxonomy. That's just binary, 0, 1. If you get in there and you're helping to write and you're generating text, original drafting, well, you got a 1 down here as well. You do those 2 things, you're already an author. In terms of just who's an author. The second stage is author order.
Gotcha.
That's the bottom. That's the bottom part down here. Yep. So that's 0, 1, 2, 3.
Cool. Crystal clear.
When questions arise, please reach out. And this is, I think I said it before, I'll say it again. So I didn't actually say it this way. If you want to be an author, you need to put your name, I'm speaking to everyone here, you need to put your name in this Google Sheet. I'm not going to put your name in here. No one else is going to put your name in here. When we go and okay, who are the authors? We go to this Google Sheet. There's nothing else. It's just this.
James, there's a question in the chat. Does participating in the sampling counts as investigation?
I would say yes. You spent your time, your energy, blood, sweat, tears, money. Absolutely. Okay. Any other questions? I'm sorry, I can't see the chat yet or right now.
No more questions.
I had a quick question. Do we have a document? Is this just like a general document, or do we have one that's specific for this manuscript?
This is the one.
This one? Okay. Cool.
Yep. Yeah. So this, I know I put an example in here, but this is the document to put your stuff into, your name, all your things. Similarly, this is the code of conduct. Hopefully, I don't know how my screen's sharing. This is the code of conduct for this paper. And this is the anonymous reporting form for this paper. Is that helpful?
And those direct links are what I put in the chat and are also in the slides.
Awesome. Okay, I think we have one more thing to do. Got 11 minutes. Someone shout at me if I should be doing something else. We have this slide. I'm gonna go to big screen. Avni, do you want to do this? Do you want me to do this? Someone else? Up to you.
I think Amy and I can tag team it.
Great.
I know she wrote in some text today. And yeah, we don't have a lot of time left, so I want to make sure, if people have questions about the science, questions about the process, just things that are super unclear, if this is your first time engaging with this group, please just raise your hand at any time, because some of what we're talking about on this slide, we can also talk about next time. So yeah, so it's more important that kind of folks are coming along with what we're trying to do here. All right, so the next thing to discuss, and we will largely do this next time, but we'll just plant the seed, I suppose, is to think about the writing process and how specifically kind of it'll go, like what are we going to do during the meetings, what are we going to do outside of the meetings, and things like that. So we had been thinking about some different co-writing models, and we'll continue to think and refine, but we welcome feedback on this front too. So one model is that we can divide the manuscript into 3 or 4 or maybe 5 teams, right? So one team for each subsection and one team for methods and one team for SI. And then the teams could have an informal lead if that helps move things along. And then every time we have this set meeting, which is a fixed meeting, we can go into breakout groups with our team and kind of make progress on that. So that's one sort of model. Amy, did you want to talk about the other options that you wrote in?
Sure. I think overall, there's sort of a spectrum of how much we could all be writing and how much we could all be editing. And so these sort of span that, but if there are other visions for that, then love to hear them. So I think on the other kind of end of what Avni just described, where people are doing all of the writing and producing an actual completed draft, it could be that maybe everyone here just wants to give feedback and edits and wants the people who've been sort of creating content so far to draft the paper, and they're just like, cool, yep, give me a section, I will give you edits on the methods. And then the other option here is a small team that's decided from this group of people, not necessarily the people that have been involved so far, generates a first draft, and then there's edits that go out from there. And so there doesn't have to be a singular way of being involved. If you yourself are like, I would love to be involved, but I don't actually have time or interest in writing a whole section or writing a whole section with other people, but I definitely want to give feedback and be engaged, that's fine. And if you are like, I want to write as much as I possibly can, I want to be all the way in here, that's also fine. I think we just need to pick a path that we want to take. Bree, yes.
I just wanted to jump in with some logistics as usual. So moving forward, what the plan is weekly co-working meetings at this time. So Thursdays 10:30 to 11:30 Pacific time. And we are going to I'm going to send out an email with the recording of this and a Google form where you'll say, yes, I want to be added to that meeting series, or I want to be included, but I can't actually make it at that time. And then we'll go from there. So just wanted to throw out those details.
Yes, thank you, Bree. And then we put these sort of timeline concepts in, which are also something that we can discuss more at the next meeting. So trying to figure out what's an amount of progress that feels comfortable and productive and good to people without being overwhelming or completely impossible, knowing that people's schedules tend to get a little bit wonky once we get into mid-November and December. So do we want to try to accomplish a certain amount before that, or just not do that? Yeah, Nick, go ahead.
I just want to be clear on where and what we're signing up. So should we be filling out that spreadsheet contribution tracking sort of aspirationally of like, I would like to review, or is there going to be some email or something where we're signing up for teams or something? Yeah, maybe I missed that.
I think those kinds of details we'll kind of figure out as we kind of go along. We don't have to figure out everything today. The Google form I have is just like, yeah, I want to be added to the meeting, not necessarily the logistics part yet.
Sweet. So more to come at the next meeting.
Yes. In general, in the past, I think the way that we've used that spreadsheet is less aspirational and more this is what I actually did,
Gotcha.
so that we have an accounting of what people believe they actually did, and that we don't have to go back and then revise it when people are like, ooh, just kidding, I didn't do these things that I had hoped to do.
So I haven't reviewed a manuscript yet because there's no manuscript that's been shared.
Indeed, yes, yeah.
Gotcha. Cool.
Bill?
Yeah, I think an important question it's popped up a little bit in the chat, and I think it's important to talk about it generally, is that most of the parts, I think the writing section separately is a bad idea. And the reason I think that is because the sections should necessarily connect to each other. the more they connect, the better the paper is. The less they connect, typically the worse the paper is. And so, for example, results and discussion. Obviously, you're going to discuss the results. Well, if somebody else wrote the results, then you're not sure what the discussion is going to be, and vice versa. So I would argue for the model where the paper is scoped out and a draft is written by a smallish number of additional people, and then everybody has a chance who wants to be who has said they've done authorship, I guess, up till that point, even though they have a chance to edit and review and think hard about it. And honestly, there's a lot of work that can be done in a paper like this that is not good for weekly 1 hour meetings. It's like, no, I need to sit and think for 2 hours quietly and actually digest the message and rewrite it is what, is what I usually do. I mean, it depends on what stage the paper's at, of course. So that would be my pitch based on, having written a lot of large author number papers.
Yeah, Bill, I definitely agree with that kind of, it does become a lot of work in the end if you have also multiple voices that you then have to unify at the end. So yeah, so people that are writing in their preferences in the chat, don't worry, we're not like holding you to this. I just wanted to get a sense of what people prefer, what people's experiences are. So it's useful to have this input. And then I think in the next meeting, we can come up with a more formalized way to progress, right? Team, what do you think? Yeah, that's a good.
Yeah, I think we're trying to just hear how people are feeling in general, and then yeah, move forward from there. Just kind of a little bit of a vibe check. And yeah, James wrote in the chat, if there are folks who know now that they are interested in writing original text, then if you want to volunteer for that, then that's also helpful to know now. If you're not sure, I think that's also okay right now.
So I'm guessing the folks that said 1 are more in the camp of could help write original text, and then the 1.5s and the 2s are in the other camp. That's how I'm interpreting it, but feel free to speak up if you're thinking differently. Allison?
Yeah, hey. I think for me, I'm one of those 1.5 folks, and I might be more of a 1 or more of a 2, depending on, my time digesting all of the content that we've seen today, right? Because like I haven't seen any of this since the original brainstorming meeting. There's a lot of really cool new analyses and things that I feel like I kind of need to chew on a little bit. So I was wondering how you would like us to communicate that. So, like, for example, if I sit quietly with the documents, look at the presentation again, review the recording or whatever, again, kind of digest a bit, and I'm like, oh, I really want to write, this section or whatever, how would you like that communicated after the fact of this meeting?
We could give folks time to digest and then have a separate place. So not the co-authorship credit and all that stuff, but a separate place where we line up the different sections of the paper, and then people can put their name next to the section that they would be most interested in writing about. So that's one way. Amy, do you have other ways that you've done this in the past? I know you've done this more than I have.
I think that idea makes sense to me. It's sort of like what we did with the analysis team previously. Like if you looked at the older document that was dropped in the chat, you could see like it's like analysis team and a list of names, and that's because people were like, I want to do this. So I think if we did something similar with the existing document and just wrote out the sections, and people can drop their names in if they feel like they want to contribute, and no one's locked into anything at this point. But if you're feeling that, then write your name.
Awesome. That sounds great to me. That answers my question. Thank you.
So we're out of time. So I think we have a lot to think about, and we can maybe, yeah, put together some materials in an email and the plan forward in the next week or so. James, did you want to say anything before we end?
Just building on that, I suppose. I put this in the chat. I guess as a process suggestion, there's the storyboard. And before anyone starts like generating paragraphs, I do think it's helpful for us to generally all be on board with the storyline. I think we can all appreciate if you start just writing and then it's like, whoa, that's not the storyline. It becomes quite difficult. So I would suggest as you have time, take a look at that, read through it, put comments in, especially from a high level structural perspective. Like this doesn't quite flow. Maybe we need to think about this idea here. That kind of thing I think would be a nice element. Beyond that, just want to say thanks to y'all. Love doing this as a community. It's super rewarding and I hope helpful and useful to y'all as well. Tell us how we can improve. Always want feedback too, please. Thank you.
Well,
Thank you all
bye.
for joining. Bye-bye.
Bye, everyone. Thank you.